The open source community is backing OpenEnv for agentic RL. You can see a long list of people that are involved with this, and some of these people are like people that are working on all different aspects of the industry. So, like for example, Will Brown works at PrimeRL, and I don't know. There's a bunch of different people here that are like working on a bunch of different parts of this, and you can see the list of companies that are listed here. So, to me, this is very exciting, just based on the participation, just based on who's all involved, because having an open source spec, it means nothing if nobody's bought into it. So the fact that like Hugging Face, PyTorch, Reflection, Unsloth, NVIDIA, Microsoft, Prime Intellect, Modal, Mercor, Fleet, RadixArc, these people have all bought in is very exciting. And I was looking, there's like Microsoft supports this in their Azure Model Studio or something like that. Prime Intellect supports this in PrimeRL. Hugging Face supports it in TRL. So there's a lot of good support that's coming for this spec. It's exciting. In also VLLM, SkyRL. SkyRL, it basically builds an open source variant of Tinker. Axolotl. So all these, so there's just a ton of buy-in, which is great. But you might be saying like, why? What's the point? The point is this, that there's a bunch of different trainers out there. We've got the Azure Model Studio. There's all these different trainers for basically taking a reward signal and turning it back into the training into the model weights. We've also got a bunch of different harnesses. We've got things like Pi. We've got Open Code. We've got Codex. We've got Claude Code. So we have all these different harnesses, and there's going to be more. And then we have there's like different environments. There's like a bunch of different environments, but the environments do not conform to any standard. There used to be like an OpenAI gym, but if you look at this, it's been deprecated. It's a public archive. It's been deprecated since, well, only April 7th, but it stopped support in 2021. But this has been dead for a really long time. But this was kind of like an early version of what you could consider like a common standard, where you had like gym.make and it would create an environment, and then you could reset the environment and get an initial observation and some information, and then you step in the environment with an action and you get like all these things. And when you look at this, you're going to notice this is kind of a standard machine learning concept at this point. We've got this. But if OpenAI Gym has been deprecated since 2021, and we've got all these new training modules. We've got different trainers. We've got all these different harnesses. This gym was never meant to work with like the open code harness or with Claude Code. Like it just was never meant for that. And then this Python definition, it's like reset, step, make, reset, and step. That's fine, but that's just a Python spec. So what if I want to write some code in Rust? Or what if I want to write some code in something else? So you're starting to kind of see this, right? That we've got all these trainers that have standardized ways of loading language models. We've got harnesses, which have standardized ways of loading these various models. But we don't have a standardized thing for like this environment or how to plug it all together. And that's the thing that's kind of like it's one of the big things that's been holding back open source in general. Like it's hard for when one company comes out and creates an incredible environment, it's hard for all the other open source companies to plug it into their inference stack and their training stack. They're not saying what your outputs of this need to be. They're not saying that like you need these specific reward signals or you need these specific observations or you need this particular shape of info, right? We need a protocol so that any language of any harness can plug in their trainer, their harness, and then plug into any of these environments that conform to the right protocol. And so this has become that interoperability layer on the surface. And it says in practice, this means one interface, many environments will all exposed the familiar gymnasium style API, meaning reset, step, and state, which you've seen from this. Reset, step, and then I guess this is sample, state. Running on a client-server architecture. So a trainer that speaks OpenEnv can drive any compliant environment without bespoke code. And so there's interoperability across env libraries. Also, things like, so when we're talking about the agent world, agents are served over HTTP and WebSocket and packaged with Docker. MCP is a first-class citizen, right? So that like, if you have an MCP server, you don't have to write custom code to figure out how it fits into this environment, how it fits into that environment, how it fits into this trainer. MCP becomes this first-class citizen where all the trainers and all of the environments know how to load it in. It's got a standard description language already, so MCP just slots in. And then we're talking about like all these new things that they're going to do, more external rewards, and task sets versus data sets, which is an important thing, and more different harness integrations and end-to-end examples. We've seen a lot of this. We've actually seen a lot of end-to-end examples. But so this was the post that got me all excited about this project. I'm thinking, hey, there's a bunch of buy-in. It seems like it's attacking the right thing. It's a protocol. And I would like to use it. But so here's what happened for me though, is that I went over to OpenEnv, like this interface library, and I got very confused. I was having a hard time figuring out what is the protocol? Because what this is teaching here, you'll see, is like, how do I import OpenEnv, the Python library, and execute Python code? It's saying here, you just saw it in action. env.reset, env.step, env.state, env.close. So it's like, it's showing it here, but then you go up to like what it just demonstrated, and it's like, show OpenEnv observation. And it's OpenSpielEnv, and it's this GRPO utils thing. So I'm thinking like, what the heck? I don't understand what this is trying to demonstrate. It's like showing me a specific Python import thing and then telling me it's something else. And okay. So then we've got this like play random policy. It's got these actions. It's like different API. And then this is trying to teach me about GRPO and reinforcement learning. I know what that is. Like I know how this is, but this is very strange. And it's teaching me like from PPO to GRPO. So this is like the first example that you get when you go onto the site. And it's saying, okay, where it's going to do group optimization. You need like, it's going to do group relative rewards. Great. It's just trying to teach me RL. And it's trying to teach me PyTorch. And TorchForge, which I think is TorchForge even deprecated? I think it's like deprecated now. Yeah, development in Forge is so it's teaching. It's like the first example is coming from a deprecated thing using incorrect implementations that don't match the new thing, and there's this open spiel. Like it's very confusing. So then I thought, okay, that's weird. Let's look at more examples. And so I started looking for like different, more legible examples. OpenEnv simple. And this is cool because it's like, okay, I'm starting to see, I got a basic instruction. I'm importing this open code env. There's like a rollout result of some type. So there's like a library here. There's like a framework inside of this OpenEnv stuff where I can like, this is coming straight from the OpenEnv stuff. So I'm thinking that's pretty cool. But it's hard because like in OpenEnv here, they're talking about this basic gym environment, but then in here, I'm not seeing here, like, let's see step. There's no step. There's no reset. So that's not great. I'm excited about the concept, but like I was looking for the actual, where's the protocol? So I'm on board with the idea for there being a protocol. I'm on board with there being a library to even demonstrate the protocol. I'm down with like a lot of the parts about this. And it looks like there's all this stuff, right? Like, but wait, my question is, and this shows how to run an environment. It shows like the sync step, client.step, and how to call it, like call a tool call. So it shows you how to like use their library and like their library's abstractions on top of their library in order to drive this protocol. But my thing is just like, what is the protocol? What's the actual protocol? This OpenEnv protocol that they talk about. Like, what is this? And what is a protocol? It's saying so clearly that it's a protocol layer, not a reward framework. And so I was really having a hard time figuring out, where does the protocol end and the library start? And where, like, for example, if I use primerl, what part of that needs to be exposed for OpenEnv? And so I created this project over the past week called miniopenenv. It's a vibe coded thing just like any other, but I had it figure out exact, and I made it in C99, because I was worried that any other language that I chose, there was going to be some open source thing that it could like search for, find, and like include. And I wanted it to be difficult to write. Like I didn't want it to just be able to spit out code. It must conform with the OpenEnv spec in Python. And so by doing C99, doing C, it made it so it had to be very intentional about what it supported. And you can even see like the reference implementation, Hugging Face OpenEnv, is 752 Python files and 164,342 lines. And the protocol is buried inside those lines. It's just and here's what it is. It's a JSON envelope with 4 keys. It's 7 WebSocket message types, and it's 16 routes. Many of these are not even necessarily needed. So what I did is I had my agent download the env spec, boot up a bunch of environments, and capture the traffic and figure out what is the actual underlying spec. What's the protocol? I created like a docs page, and this docs page is really nice because it gives you like a couple of different doors to go down. First of all, you can like figure out what is the protocol. What is the protocol? Which, let's just talk about that. This is the protocol. The openapi.json lists out the routes that are available. This is like a standard thing. There's a /list environments, which gets the list of all environments. We've got, there's this concept of this task API, but nothing ships it yet. This is like an RFC that's it's a proposal to the spec, but not actually there. There's a WebSocket request for MCP, which allows you to do, by the way, like as I had it create this documentation, it also has by itself, it created spec gaps and reference warts. And so if you look at like gaps and warts, it found 24 gaps in the spec. And a lot of these are like sequencing. What happens if this message comes before this message when it's not enforced? What happens when like, do you have to call reset before you do everything? Or is the first one reset automatically? Like there's a bunch of these gaps where there's just not a defined part of the spec. But then this wart is like, the reference does this odd thing and we reproduce it. And it found 28 warts. For example, the claim /reset starts an episode and step advances it, because that is what the names mean and what every RL API does. And in our reference, each handler runs. So this is each reset, each step request. It runs self.envFactory and then closes it. So the instance that served the request is destroyed before the response is written. So if you step and you pass it amount to 3 times, then you would expect it to do 2, 4, 6, right? You'd want it to like, when you load you'd expect it to be incrementing each time. But each time it's just adding 2 to 0. the encounter environment returns total 2 3 times, and then the nested metadata reads steps 1 each time. So it's like stateless in a dumb way. So basically, it's not a stateful protocol if you use the HTTP endpoint. If you do /ws and you open a WebSocket, then you get the good behavior that you would expect, where changes of states result in the output that you would expect and the state changes that you would expect. Yeah, this is called the stateless surprise in this one. This is the API. You can get the state, even though it doesn't really make sense. You can get the metadata, even though it doesn't make sense. There's a health endpoint, which is just a good idea to have. There's a schema endpoint, which is great because you can have, it's like basically a self-describing API, similar to the OpenAI API.json. Schema means that it shows you a JSON schema for the action and the observations. And then posting to the MCP allows you to do the JSON RPC for the MCP stuff. But here's the main thing. Like, this turns out to be, like, this seems like this was an idea, but nobody's using it. And this seems to be like the thing that everything uses, which is the WebSockets. WebSocket, when you open that and you send these JSON, this is the real protocol right here. Sending the reset, type reset to the WebSocket that you've opened here. Calling step, getting state, asking for state, closing it, and MCP. And then what you get back through the wire is observations from your steps, states from your state requests, errors from any errors that happen, and MCP responses. So that's the envelope. And then they say every observation is in this envelope. It's observation, which has a whole object that can be whatever. The reward is a build, like the reward from like the environment. Done, whether it's finished, and then metadata. So this is what this was talking about, is the stateless surprise. The route table is marked reset and step stateless. And that word is doing more work than it appears to. A counter stepped twice over HTTP. So this is me saying, this is what it's saying again. 2, then 2 again. Now, if you do the same over the WebSocket, OpenEnv WebSocket probe, which is like this thing that this built in miniopenenv, and you say run 2 steps where the action is amount 2, you're going to see that it actually increment. So when the WebSocket stays open, it becomes stateful. And so then the agent created this whole list of oracles where it compares an agent that's driving like an OpenEnv Python env from Hugging Face that's driving it versus my C library that's driving it. And through all of these, we were able to match it byte by byte. So that's pretty cool. And so if you look at like the different line counts, there's just like way more stuff in the OpenEnv reference, whereas this is just tiny, it's minimal. And so, okay, implementation of the OpenEnv protocol in C. There's a reference implementation in the Python server that's like 109 lines. This is a lot more, but we're completely building everything inside this one C file. And so you can see like we're just importing buffers, HTTP, JSON, nets. Okay, there's stuff in the wire, I guess. But yeah, the protocol is much simpler. It's just reset. There's some, so this is a little bit not pedagogical because it's hard to read through it all. It's C, but this is all you would need to do to implement using this C library. Go. Annotated episode. This is what I wanted to show. Because yeah, I'm glad that it like created this. We've got a conformant thing like that. This one is a minimal one where it's just doing the bare minimum. This is more conformant where it's doing more things. And we're pulling in from OpenEnv, so it's got some more like in this OpenEnv.h. There's a lot more convenience functionality. So you pass like these are the fields that are available on the counter environment. These are the observable fields. So like there's an amount, there's a total. Like the running total is like an observation. The amount is how much that you're going to add to it. And then every time you add an amount to it, you get a new observation with these new totals. There's an actual counter that is the struct in C that's going to store this stuff. We've got the actual function that does the work. This is the actual meat of the environment itself. We've got a reset function that like knows how to take this counter struct and reset the total and the steps to 0 and reset it, and then knows how to save that out. We've got a counter step where we're going to parse out the amount. We're going to add that to the total. We're going to add 1 to the steps. We're going to set all this stuff on the fields, and we're going to say we're done, and then recalculate the reward. This is another one for the encounter state. And then this is like a little description where we're creating the environment with a name, with a description, with a task environment name, with the action fields we talked about, with the observation fields we talked about. So this is like a convenience wrapper creator using, this is kind of like what the nice way of doing it, using the OpenEnv.h that this agent created. So this is like the crappy manual way with a lot of code. And then this is like a nice conformant, easy to use one. And then here's a client where it's a client of the server. So it's doing both ways. This is the implementation of the server, and this is the client of it. And this is like crappy. Like you would not use this. This is just a way of like debugging and showing like what a client might look like. In fact, I'll demonstrate it in a minute. And then we have examples. Well, I'm not going to do that right now. Okay, but going back to this annotated one. So this was one where like I told you I had it download an environment and like run some stuff through it and capture the output and use that to build our implementation. Okay. So this is the annotated back and forth where I captured a bunch of traffic, and this shows exactly what the protocol is. It makes it easier to understand, in my opinion. So it started out, there's an opening handshake. You get the WS WebSocket, and WebSocket does an upgrade. This is a standard HTTP request. That HTTP request upgrades the socket into a WebSocket. Now it's a WebSocket. From here on, every message travels in a frame, a short binary header, then the payload, which is the message itself. The header says what kind of payload follows, the opcode, how long it is, and whether it is masked. Frame 1 spends 6 bytes on the header and 26 on the payload, and the annotations read the header back a bit at a time. Masking is the one rule that differs by direction. A client XORs every payload byte with 4 fresh random bytes called the masking key carried in the header. A server sends its payload bare. RFC 6455 requires both, and that is why a captured client frame looks like noise, while a captured server frame is readable text. The message inside this frame is reset, start an episode, and send back the first observation. So when you first connect to it, once you connect to it, a WebSocket, it upgrades to the WebSocket, and then the first thing is, so this is sending the frame header. Byte 0 is 81, says it's text. Payload is 26 bytes, and then the following is the masking key to 4 mask bytes. Every payload byte on the wire is XORed with them. This program sent a reset message through the WebSocket. The payload as we wrote it. On the wire, every byte of it is XORed with the 4 byte key above, which is why a capture looks like noise. Anyway, okay, so then we get 2 bytes back, which is the frame header, saying it's going to be text again, and it's going to be 118 bytes. Then it sends those 118 bytes, which is an observation message. And the observation has metadata, total, and last note. That's the observation. The reward is null, and done is false. Okay. So this is the reset and the first observation. Then we're sending our header again. It's text and it's 35 bytes. We're going to say step by the amount of 2. So in our data, we have this object, and the action is that. That's the action. So if you post to /step, that wraps the exact identical object, that asymmetry is the single thing a handwritten client gets wrong first. So what this is saying is that this would be like if you post a slash step, it's going to be wrapped in an object with an action key. Weird. It seems like they don't have it figured out between what's the WebSocket and what's the HTTP protocol. Anyway, okay, so we're sending a step message. This is saying like I'm actually going to step the environment forward, and I want to like set the amount to 2 or increment the amount by 2. Then we're going to receive a frame that says it's text again. It's 126 bytes. Now this 126 bytes does have metadata. So remember, it's observation, which is the observation itself, which this is the observation, which has its own metadata. We wrote that metadata in there of steps is 1, total is 2, and last note. The reward is 2 for whatever reason. Reward is a float. On this transport, that means the environment produced a float over HTTP. It would mean nothing at all because HTTP corresponds every reward to 1. It's so like passive aggressive about that. But anyway, it still says it's not done. And now we do have metadata where there's 1 step. So we're going to send the frame header again. And basically this is the exact same thing. We're going to send the frame header and then the step, frame header and then the step. And we're going to get a response saying it's another 126, same 126 because it's the same data. Instead of having 1 step, we've got 2. Instead of our total being 2, we've got 4. And our reward is now 4. Done is true. And then their metadata includes steps 2. And that means that this environment has decided to end it after the 2. So 2, then 4. So we saw it increment. This is right. So that was the step. That was demonstrating the step part of the protocol. Now let's look at the state part of the protocol. When your client asks an environment state, which is just sending it this one message. There's no arguments with state. It's just state. It carries no data at all. It's a request for state. So then this is going to say, hey, I'm responding with text. I got 74 bytes. And this is saying, this is the state of it. It's got this data blob, and the data has an episode ID. That's just what it has decided, is to have an episode ID, have a step count, and a total. But this is all application specific. This is all environment specific. Our environment that we're interfacing with chose this as its state. And so we got that final state. And then this says close. Close ends the session and is the one message answered with silence. No observation comes back. The server breaks its loop and starts the closing handshake instead. Each side sends a small close frame and a goodbye, so the socket ends by agreement rather than by dropping. And then the probes, half of that goodbye was written into a frame header, not by any caller. So we say close. We've got this little dance, and then it's done. One question is still open. How does a client know what an action looks like? The probe never asked. Amount 2 came from its command line. So remember, we showed up here. Actually, I don't think I called it out, but this said this probe function, it connects to an OpenEnv, and then we said this episode steps 2. It's going to send this 2 times, basically, is what it's saying. It uses no protocol code of ours. So we're learning the protocol by inspecting this back and forth. So we closed it. Okay, typing channel, schema. So instead of doing that episodes, let's do a schema. So we're just going to connect to this server and ask for schema. So it sends the HTTP request to schema/schema. And then the response comes back with this big JSON blob. And 3 JSON schema objects: action, observation, and state. This is what we get back. So look at action. It's got a JSON schema. So that looks like there's going to be metadata. It's going to be an amount, and there's going to be a note. Metadata is itself an object, which can be any object. It's open. Additional properties are true. Amount is going to be an integer, just one integer. So it's going to increase or decrease, but it's an integer. And the note is a string. And then the title of, it's going to have a title called counteraction, which will always be title counteraction. So the field is title counteraction. So that was the action. It's like, what are we passing when we do step? What are we passing is this action, step of amount 1. We didn't do any with a note, but we could have. And then the metadata, what did we set when we stepped? Nothing. And then observation, it looks like it's going to have a done property, which is a Boolean, a reward property, which is a Boolean, an integer, a number, or null. We've got metadata, which is just an object. We've got total, which is an integer starting at 0. We've got last note, which is probably, I'm expecting, whatever the last thing you sent in under note, which we never did. And so this is telling you the action that you're going to send. This observation is the observations that come back. And if you look here, these are the observations we saw, where it was metadata, total, last note. And if we look here, metadata, total, last note, there was done and reward. Yeah, done and reward too. I just didn't mention that. So then finally there's state. Description is base class for environment state. Represents internal environment state, separate from observations. So this is when we asked for state here, when we sent that state message, we got back this episode ID, step count, and total. And I bet that's what we're going to see when we, that's what we're going to see when we look here. Episode ID, yep, which can either be a string or null. Step count, which is an integer. And then title state, let's see, total. Episode ID, step count, total. Episode ID, step count. Get state, which we do down here, or which we showed up here. Or where did we show it? Get state would have shown you exactly 2 keys, episode ID and step count, because it truncates to the base state model. This is a wart that it found. So I was just noticing that. So this, yeah, it seems like there's a base JSON schema, which includes total, and this truncates that, I guess. So I found this very helpful to help me understand what exactly is the OpenEnv spec. The OpenEnv spec is basically this WebSocket that has these specific JSON schema and these specific JSON keys, which you can discover and understand by asking for the schema, and that's it. That's actually it. So there's the spec, and you can like go in and read about the specifics of it and exactly what happens when a validation fails, what happens like in the stateless version of it, how a non-Python client learns the shape of this stuff, and then the MCP stuff, which is interesting. I don't need to go into the MCP stuff now, but that's all captured as well and reproduced into this library. And so this is telling you what are the things that a server must do. The server must respond with health, OpenAPI. It must have a reset. It must have this MCP. It must have a WebSocket. The WebSocket must upgrade. The WebSocket must speak this protocol, basically. And then clients have a certain set of obligations too. They have to like look up this stuff. They have to poll the health periodically. They need to open up exactly one WebSocket. They need to, send the right things there. They need to send the right types of frames. They need to encode it properly, do the XOR stuff. Apparently there needs to be, well, this is just like maybe an implementation thing, but under 16 megabytes per frame. If a server pings, it needs to send a pong. So like these are things that it has discovered that it needs to do. So I created this conformance tests, and it does all that. I do want to share like an example of it. So let's do Maze. I'm going to host it on localhost, and I'm actually going to say 8021. Hopefully that works. And then I've got this ready to go. OpenEnv connect 8021, let's say. And I want to do VV, so this is like giving a very verbose version of it. So if you look over here, session opened. This connected, you get to see it, every single thing. So it connected to the WebSocket, it called reset, it sent a reset message, and it got back an observation. The observation includes this. So this is where we start to get into like my own mini standard. So on all these arcade things, it supports a field called input text. And the input text is like from the environment to you. So it's prompting you kind of. And it also includes an X, a Y where you are, the goal X, the goal Y. So it would be displayed. It's like you know where you want to go. And we haven't gotten any rewards yet, and we're not done, and there's no metadata. So it's saying, okay, 15, this is what the text from the environment was. The environment sent back text that said a 15 by 15 maze. This means a wall. That means a floor. A means you. G means the goal. And it says you are at column 1, row 1. Row 0 is the top. We've got left, right, up, down, 0 to 9, enter, reset, trace. And these are all the things that I can trigger on my keyboard that send events to the environment, and the environment will send back. So it will call step every time I call this, right? I'm going to do right. I'm going to try and solve this maze. You can see the A is floating around. Wait a minute. I went the wrong way. Got to go up. But you see, every time I do this, I'm sending a step move and I'm getting back an observation. This is a perfect example of using an environment and how we're able to interface with it and write a little client library where I'm the person running it, not a machine. But you can imagine hooking up an agentic LLM to this, and I'm trying to get to the goal. So it says reach the goal in 95 steps, return 0.06. If I would have done it in fewer steps, it would have done more. You can see this is just an example. You can see how it works. And yeah, so let's actually just do another one quick. Instead of maze, let's do snake. Okay, I go left. Space goes straight. Straight, right. 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 Oh no. It's actually harder to steer than you think it might be. Even though you have all the, like, it's not real snake. I have all the time in the world. The harder part is that like I have to think from the snake's perspective and go left or go straight or go right. And it's like hard because I've got my perspective. So it's kind of its own different challenge. I'm getting better. But this is exactly the type of thing that like an LLM could get better at. And it might be interesting to put in your environment some time limit where if the next thing comes in too much later, it counts as a fail or something like that. John Carmack thinks this is the wrong way of approaching it. He thinks that by having the client step the environment and say, okay, now I'm ready for the next step of the environment. He's like, that's not the way the real world works. The real world is an environment that calls, like, you, when you call the next step, if you've taken too long, you might have missed a bunch of opportunity to act. And so by having the environment call the step function of agents, he says that it's going to make us create agents that have more time accuracy. If you go off and you think for 5 minutes and come back, that's not acceptable in the real world. And so there's some benefit from responding quickly and not missing anything. And so that's an interesting perspective. And I think like we will see. I think John Carmack could really be right about that. But it's not the way this is implemented. This is implemented in the classic gym way where the environment is stepped by the client. As you can see, it waited until I hit enter. Every time I hit enter, it would step forward in the environment and push one more time step forward. And that's the way this works. You could keep a counter or keep a time, like log a timestamp whenever this environment gets in the next message. And if it took a certain amount of time, you could actually skip 2 time steps ahead or something like that. Totally doable, but it's something you have to build into your environments right now. Whereas what John Carmack was saying is that he thinks it should be inverted, and by default, that's the way it should work. So we'll see how that goes in practice in the future. But if you want to check it out, you can check out this miniopenenv project. This is a project that I created using one agent over the course of 4 or 5 days, just having it like continue to iterate. It's Apache 2. You can use it as like your environment library. Like you can implement, you see that with these arcade, I've implemented a bunch of different clients. You can also use the OpenEnv client that this has created. You can use it as a client for yourself. This doesn't have to just connect to my environments that I've created. Like you could connect to an environment that's a open source one. Got a bunch of them. So you've got a code environment, you've got a math environment, you've got like these benchmarks, you've got humanities last exam. These are all OpenEnv environments now. So you could just run prime eval run HLE. Well, I don't know if that would spawn a OpenEnv or if you have to give a special OpenEnv arg, but you could spin up any of these environments here as OpenEnvs, and then you could use my client library, my CLI thing that I was using to drive this little snake game to connect to these and interface back and forth with these. So this is like the dream. And look at community. We've got people like Archie, we've got Prime Intellect themselves, we've got like all these open source people who come from the community. Will himself, for example. We've got all these people who are creating Chakra Labs. I don't even know who they are, but they've got a dojo environment. We've got Proximal Frontier Suite. We've got Frontier Suite environments. We've got Calamaze with an alphabet sort. That's interesting. Alphabet sort. This task requires the model to maintain and update an alphabetically sorted list of names across multiple conversation turns, with new names being tagged appropriately. Yeah, so just like cool little. So if you had, you can imagine like you grab a couple of these and you train a couple of these, and then you have maybe you have a bunch of environments that represent your task, your distribution that you care about, your particular type of coding, or maybe you've extracted a bunch of like trajectories from your live running service. Like if I could take these neural column, all this history and find places where like there was a mistake that was made that was corrected, we could take that and convert it into these environments and then train on that suite. So I think there's just tons of exciting stuff to do with this, but this spec needs specking. This is not good documentation. This is not great documentation. This is great like usage documentation, but not great protocol documentation. The protocol is really hard to track down. And so that's why I'm glad that like my agent did this. It created from scratch implementation in a brand new language. That's why I chose C99. It's not a good idea in general. But I had Fable, I had Opus, and I had open source things all working on it. And in the end of the day, it is a good library now. So if you go to the README, you can say like, hey, I went through the parts that help us understand OpenEnv, but you could also just like use it as a reference. You can pass this protocol to an implementation where you implemented in another language. You can use this probe stuff to connect to an OpenEnv server and annotate and check. You can use this as a OpenEnv server. In fact, there's like a little Docker container that wraps it into, like, check this out. If you run make Docker, it creates this like tiny Alpine based, Scratch based, or it uses Alpine to build and then just uses Scratch and copies the binary in there. And it ends up with a 211 kilobyte container with just the binary in there. So there's some cool stuff that this library enables. It's not something that you couldn't do with Rust or that you couldn't do with another thing. But the fact that it's just like C99 makes it just kind of like easy to do these like super slim stuff. So You've got the server, the client, the protocol, the wire. Like, it's kind of fun. I'm probably not going to keep working on this. I will potentially keep it up to date. So as OpenEnv specs out and becomes more realistically like a real protocol, like I'll track it and make sure that this kind of follows that. But who knows if I'll create a bunch of environments using this C. But if you want to, you totally can. This is a way of creating a very efficient environment for OpenEnv.